Okay, year 13, here's the second video on integration. So the next thing I'd like to do is, again using these formulas down here on the left hand side of the screen, I'd like to copy these down please in your notebook, and I'm going to go through how to use them. So again, these ones are on page 85 of your textbook if you want to use those, and again make sure you pause the video so that you can copy those down first so we can refer to them during the next examples. So the first question we're going to do is we're going to integrate cos 2x plus 3 with respect to x. Now beforehand we just integrated cos x, so the difference now, if you have a look in all these examples here, so it's now, instead of cos x, cos of something in the brackets. So if we have a look at how to integrate cos integrates to sine x. So cos of 2x plus 3 integrates to sine of 2x plus 3. But the key thing is, whatever's in the bracket, we differentiate that and then stick it underneath. So if we differentiate 2x plus 3, that's going to be 2. So we're going to stick the 2 underneath and plus c. Now usually when we do this, if we divide by 2, we just write that out as a half sin 2x plus 3 plus c. So the key thing is we differentiate whatever's in the bracket and then we stick that underneath. Okay, similarly, if we're going to integrate e to the power of 4x plus 1 with respect to x, when we integrate, so again if we go over to here, when we integrate e to the something, that stays as e to the something. So when we integrate, it's still going to remain as e to the 4x plus 1 then plus c. But whatever this thing is here, we differentiate it and then stick it underneath. So differentiate 4x plus 1, stick it underneath, it's going to be over 4. Alternatively, write it as 1/4 e to the 4x plus 1 plus c. Again, both these things are the same correct answer. Next one. If we then integrate integrate, let's try again, shall we? Integrate for the third time sec squared 3x with respect to x. Okay, if we have a look, if we integrate sec squared, that goes to tan x, tan. So if we integrate that, that's going to be, instead of sec squared 3x, it's going to go to tan 3x plus c. But whatever this is, we differentiate and we stick it underneath. So divided by 3, alternatively a third tan 3x plus c. Again, it's useful being able to know that these two things are the same thing, because very often it will be useful to put it in this format or useful to put it in that format, depending on what it is that you're cancelling. Okay, so let's go through a couple more examples and then you can crack on and get on with some of the work. So what about if we've got this sort of example now? So we've got to integrate 1 over 3x plus 2 with respect to x. So again, what we've got here is 1 over something. That's going to integrate to log of that. But we differentiate and we stick that a underneath. So this will go to log of 3x plus 2 plus c. But we differentiate this and then divide by it. So differentiate 3x plus 2, that goes to divided by 3. Alternatively, 1/3 log 3x plus 2 plus c. Again, there's not an awful lot to this. And then if we go for the next one, so we're going to integrate 2x plus 3 to the power of 4. And again, it's just slightly opposite of the chain rule that we did in differentiation in C3. So we're going to integrate that with respect to x. So we're going to keep that bracket, 2x plus 3 to the power of 5, and then we divide by 5. So divided by 5. Then we also differentiate this and then stick that underneath. So differentiate 2x plus 3, that goes to 2. So we're going to stick the 2 underneath as well, and plus c. So 5 times 2 is going to be 10. So we leave that as 2x plus 3 to the power of 5 over 10 plus c. Alternatively, take the 10 to the front, so that's 1/10 of 2x plus 3 to the power of 5 plus c. And all of that stems from this stuff here on the left of the screen. Okay, what I'd like to do now is have a go at exercise 6b and see how you get on with that.